Hello, I'm Kritika Tank. In this video, we are going to learn about data processing instruction. So let's refer to the set of operations performed on data within the microcontroller's CPM. Today's agenda. We will start off by talking about instructions in microcontrollers used for data processing. Then we will look at various types of data processing instructions and learn more about them. Finally, concluding with a summary and a quick question for you to answer. So, what are data processing instructions? These are the instructions that allow microcontrollers to manipulate and transform data according to specific requirements. These are the fundamental arithmetic and logical operations of the processor, and they operate on values in general purpose registers or a register and an immediate value. Registers used in the ARM procedure core are R0 to R3 and including R12 are called scratch registers. R0 to R3 are used to pass parameters. R12 is an intra-procedure scratch that will be overwritten by subroutines. R4 to R11 are preserved registers. They are stacked before using and restored before returning. R13 is the stack pointer. R14 is called a link register, and R15 is a program counter, which will point towards the next instruction that is supposed to be executed. So now we will look at different types of data processing instruction. Data processing operations include arithmetic and logical data processing instruction, shift and rotate data processing instruction, and control flow instructions. Now let's learn more about each of these. The first one is arithmetic data processing instruction. These are instructions used to manipulate numerical data in microcontrollers. They enable microcontroller to perform basic arithmetic operations such as addition, subtraction, multiplication, and division. Arithmetic data processing instructions help perform mathematical calculations necessary for tasks such as sensory data processing, numerical computation, and algorithmic operations. Arithmetic instructions are implemented using dedicated hardware circuits in microcontrollers for efficient execution. Some examples of these instructions are ADD, SUB, ADC, SBC, NEG. Some instructions have an S suffix, indicating that the instruction sets control flags. The operations ADC and SBC performs addition and subtraction. They also use the carry control flag as an input. Next, we have logical data processing instruction. The logical operations are essentially the same as the corresponding Boolean operations operating on the individual bit of the registers. These instructions manipulate bit binary data at the bit level. Logical data processing instructions in the microcontrollers perform logical operations such as AND, OR, XOR, and NOT. They enable tasks such as data filtering, signal extraction, decision making based on logical condition. Logical instructions are commonly used in conditional statements and bitwise operations in microcontrollers. Few examples of such instructions are AND, BIC, ORR, ORN, EOR, EON. AND stands for logical bitwise AND of two 32-bit values. BIC stands for logical bit clear. ORR stands for logical bitwise OR of two 32-bit values. And EOR stands for logical exclusive OR of two 32-bit values. Now let's look at shift and rotate data processing instructions. Shift and rotate instructions are essential for bit manipulation and data alignment in microcontrollers. They enable microcontrollers to shift bits to the left or right insert or extract data from specific bit positions, and rotate bits in a circular manner. These operations are useful for tasks like data extraction, bit masking, and cyclic data processing. Shift instructions move bits left or right when rotate instructions circulate the bit within a register. Few examples of such instructions are LSL, that stands for logical shift left. This instruction performs multiplication by a power of 2. Next is LSR, logical shift right. This instruction performs division by a power of 2. Then we have ASR, which stands for arithmetic shift right. This instruction performs division by a power of 2, preserving the sign bit. Last one is ROR, rotate right. This instruction performs a bitwise rotation, wrapping the bit rotated from LSB into the MSB, least significant bit into the most significant bit. Lastly, we have control flow instructions. Control flow instructions enables microcontrollers to determine the execution sequence of program instructions in the microcontroller. These instructions are unconditionally executed, but use the conditional flag as an extra input to the instruction. Control flow instructions enable microcontrollers to make decisions and repeat or jump to specific part of the program. These instructions include branching, looping, and subroutine call instructions. There are a small set of conditional data processing instructions. Examples of such instructions are EQ, that stands for equals to, which sets the conditional flag Z as equal to 1. The next is NA, which is not equal to, which sets the conditional flag Z equal to 0. Then we have CS, which is carry set, which sets the conditional flag C, that is for carry, is equals to 1. Now let's summarize what we have seen in the previous slides. Are you ready? We have learned that data processing instruction in the microcontroller enables manipulation and transformation of data. We know that data processing instructions in the microcontrollers contains a broad set of operations that facilitate efficient data manipulation within the CPU. They include arithmetic, logical, shift and rotate, data conversion, memory access, control flow, and vector processing instructions. These instructions are essential for executing algorithms, performing calculations, and controlling the behavior of microcontrollers. Now it's time to test your knowledge. Share your comments answering the following question. What are the data processing instructions in the microcontrollers? I would look forward to hearing from you what you have learned from this video. Thank you for participating. Have a great day ahead.